Dear students, today I'm here with the topic displacement reaction. First of all, the definition: the chemical reaction in which a more reactive element displaces a less reactive element from its compound is called displacement reaction. We have learned about combination and decomposition reaction. Now the third type of reaction is a displacement reaction, and this displacement reaction is different from combination and decomposition reaction. So as the name suggests, displacement. So what will be displacement? That is, in this reaction, an atom will be displaced by another atom. So there will be displacement of atom. So an atom or element will be displaced by another element or atom. This type of reaction is called displacement reaction. And so clearly we can see that a more reactive element displaces a less reactive element. This type of reaction is called displacement reaction. So we will see an example of this displacement reaction, then you will understand more about displacement reaction. We are going to consider this reaction, this example, that is, iron displaces copper from copper sulphate to form iron sulphate and copper. So it is a reaction. It is an example of displacement reaction. For in this reaction, we need beaker. So from the figure you can see that first of all we need a beaker, and for this reaction we need two reactants. Two reactants are, we need iron and copper sulphate. Okay, so iron, how can we get iron metal? So for that we will take an iron nail. So iron nail is made up of iron metal. So the first reactant, iron, is in the form of iron nail we have. Second reactant is copper sulphate. See, copper sulphate, its formula CuSO4. Copper sulphate is an ionic compound. It is a blue color solid. For this reaction, what we have to do? We have to make aqueous solution of copper sulphate. How will we make aqueous solution of copper sulphate? Add small quantity of copper sulphate powder in water, then you will get copper sulphate solution. So first of all, we will take a beaker like this. In this beaker first, and we will pour 100 ml of copper sulphate solution. So copper sulphate is a blue color solid. It is dissolved in water and you will get aqueous solution of copper sulphate. Then this is the one of the reactant. This is one of the reactant. What is the next reactant? Iron. For the iron we will take an iron nail. After that, after taking copper sulphate solution, aqueous solution of copper sulphate in this beaker, we will dip the iron nail in this beaker. So you can see the picture like this. First of all, copper sulphate solution. In the solution we will dip an iron nail. Now so what are the reactants here? Iron and copper sulphate. Now actually what happens is that there will be displacement reaction. Then displacement reaction takes place between iron and copper sulphate. As a result, you will get two products, iron sulphate and copper. So displacement reaction takes place. So after dipping iron nail in this copper sulphate solution, we have to keep this beaker for some time. For say we can say for 30 minutes, keep this iron and copper sulphate solution in this beaker. Keep it there for 30 minutes or 1 hour. After 30 minutes or 1 hour, check the beaker, and after 30 minutes you will see that the blue color solution now is changed into a green color solution. So after 30 minutes you will see instead of blue color solution there is green color solution. Okay, and what about the iron nail? Iron nail, iron nail will be like this. That is, there will be a coating on iron nail. That means there will be a reddish brown colored coating on iron nail. So now can you say which are the products here? This green color solution is the first product, iron sulfate, aqueous solution of green iron sulfate solution. Iron sulfate which is in green color. So that's why you will see green color solution. And second product is copper metal. So due to the formation of copper metal, that's why you will see reddish brown coating on iron nail. This is reddish brown coating is what? The copper metal. And what is the green solution? Green solution is iron sulfate solution, because iron sulfate, the color of iron sulfate is green. So this reaction is displacement reaction. So in this case we can say that where we will take blue color copper sulfate solution. In this copper sulfate solution we will dip iron nail, keep it there for some time. After some time you will see instead of blue color solution there will be green color solution. This green color solution is iron sulfate. And the iron nail, there will be a reddish brown coating on iron nail. This iron coating is, this reddish brown coating is the copper. Okay, now I'm going to explain why this reaction is displacement reaction. Because when you check this reaction you will see that, can you write the equation? What are the reactants? First reactant, iron nail. So iron nail, how will you write? Iron, formula of iron, Fe, iron metal. So in the case of metal we will write only symbol. Second one, copper sulfate. Copper sulfate, find the formula of copper sulfate. Copper Cu2 plus sulfate SO4 2 minus. So you will get CuSO4 gives. After that, the first product, the green color solution is iron sulfate. Iron sulfate, its formula FeSO4. In this case, the valency of iron is taken as Fe2 plus. Okay. So last year we have studied that iron has two valencies. Fe2 plus is there and also Fe3 plus. Okay, but in this case, in the case of this iron sulfate, it is iron 2 sulfate. So here we will use, here the valency of iron is used 2 plus and the sulfate SO4 2 minus, then you will get FeSO4. Okay students, here iron, which iron is here? Iron 2 sulfate, not iron 3 sulfate. And iron 2 sulfate, its formula FeSO4, it is green in color. And also the what about copper sulfate? Copper has two valencies, Cu plus and Cu2 plus. Here which valence is used? Cu2 plus is used. So actually this is copper sulfate, means it is copper 2 sulfate. So iron 2 sulfate, you will get formula FeSO4. And the second product is Cu. Copper metal, its formula Cu. So FeSO4 plus Cu. Now the displacement, we will see the displacement of this reaction. Here you can see that iron displaces copper from copper sulfate. Okay, this is the displacement. So iron displaces copper from copper sulfate. That is, iron occupies the position of copper in copper sulfate. Then instead of copper there will be iron. As a result, the product will be iron sulfate. And this displaced copper will be in the form of pure metal. Okay, this is the reaction. We have iron is displacing copper from copper sulfate. That means iron takes the position of copper in copper sulfate. So copper lost its position. Instead of copper, now who will occupy the position? Iron. So the product will be FeSO4, and this displaced copper will be in the form of pure copper or pure metal. So this type of reaction is called displacement reaction. That is, one atom displaces another atom. Here copper is displaced by iron, or in other words I can say that iron displaces copper, and instead of copper which will come? Iron, that is FeSO4. So this type of reaction is called displacement reaction. And now the question comes in your mind is, how does, or why, what is the reason behind it? Why does iron displaces copper? What is the reason behind it? The reason is that iron is more reactive than copper. That's why. So the condition for the displacement reaction is that a more reactive element displaces less reactive element from its compound. This is the condition. So in which case the displacement reaction will take place? There should be difference in the reactivities. Then only there will be displacement reaction. Here iron is more reactive than copper. Therefore, iron can displace copper from copper sulfate and form iron sulfate and copper. So this is the condition. So a more reactive element, here iron, displaces a less reactive element. Which is less reactive element? Here copper, from its compound. Okay, now is it clear? For displacement reaction there should be two reactants. There will be two reactants in every displacement reaction. Out of these two reactants, one of the reactant will be in elemental state. In elemental state means pure element like iron, gold, copper, silver, or any pure element. It is not compound. And the second reactant will be a compound. Okay, now can you identify the conditions of displacement reaction? There should be two reactants. Out of these two reactants, one of them will be an element. Means there will be only symbol of an element, plus second product will be, second reactant is a compound like copper sulfate, iron sulfate, sodium chloride, potassium chloride, silver nitrate, like compounds. And what about products? How many products will be there? Two products. Two reactants, two products. And out of the two products, one of the product will be compound and the other product will be free element in free elemental state. So there should be two reactants and two products. One reactant and one product will be in free elemental state. It should be free element, and the remaining other reactant and other product will be compound in compound form. So like this will be the general form of displacement reaction. Now what is the condition required for displacement reaction? There should be difference in reactivities. And difference in reactivities means more reactive element can displace less reactive element from its compound. They are reverse. Opposite is not possible. Opposite means uh, less reactive element cannot displace a more reactive element. Okay, now here we have seen that iron displaces iron displaces copper. Iron displaces copper and form iron sulfate and copper. So what the reason we know that iron is more reactive than copper. That's why iron is able to displace copper. So now why there are different reactivities in the case of elements? So especially in the case of metals, you can see that the reactivities of metals are not same. It will be different. That is, some of the metals will be highly reactive and some are medium reactive, moderately reactive, some are not reactive, very less reactive. etc. So the reactivities of metals are not same. So here in this case, in this reaction, when you compare the reactivities of iron and copper, iron is more reactive than copper. That's why iron is able to displace copper from copper sulfate and form iron sulfate and copper. Now there is a reactivity series of metals. That is, the reactivity series of metals is helpful in determining which metal is capable of displacing other metals from their compounds. Now this series is called reactivity series of metals. So reactivity series of metals means actually it is an arrangement of metals in the form of list. So it is a form of list in which we will arrange the metals in decreasing order of their reactivities. See the arrow mark. We will, in this list is called reactivity series of metals. So in this series, we arrange the metals in decreasing order of their reactivities. That is, down this series, down the list, the reactivity decreases. So this series helps us to understand which metal is more reactive and which is less reactive. So using this series of metals, that is, this series is called reactivity series. So how will you define reactivity series? Reactivity series of metals is a list of metals in which the metals are arranged in the order of their decreasing reactivities. So this series is called the reactivity series of metals. Using this series, you will understand which is able to displace and which element is not able to displace, etc. So, uh, this series, so it is given in your textbook. It is not in the first chapter. It is given in the chapter number 4, metals and non-metals. So you can see that, you can check that, refer the textbook. This series is given in the chapter number 4, metals and non-metals. And in this series, what is the importance of this series? From this series, we can understand the decreasing reactivities. That means down the series, the reactivities of metals decreases. That means potassium, first metal, you will see potassium is the most reactive. Then down potassium, next one sodium, third one calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, and the last one platinum, least reactive metals. So that means the reactivity decreases down. So the most reactive will be potassium and the least reactive metal will be platinum. So for example, if you consider the reactivities of zinc and silver, which will be more reactive? Zinc is more reactive. How can you know? Because if you know this reactivity series, then it is easy to find, because when you go down, the reactivity decreases. In this case, zinc is above silver. If you consider zinc and silver, zinc is above silver, so zinc is more reactive than silver. Similarly, if you consider potassium and zinc, which is more reactive? Potassium is more reactive than zinc, because potassium is above zinc in this series. If you consider zinc and lead, which is more reactive? Zinc is more reactive than lead, because zinc is above lead. If you consider copper and silver, which is more reactive? Copper is more reactive than silver, because copper is above silver. So this series is called reactivity series of metals. Using this series, you will understand which metal is more reactive and which is less reactive. So this is the significance of reactivity series. Now back to our reaction. Here we have the reactants iron and copper sulfate. Now can you check the reactivities of iron and copper? We have seen that iron displaces copper from copper sulfate. Now check the positions of iron and copper. Where is iron? Iron here. Where is copper? Here. So if you compare the positions of iron and copper, which is more reactive? Iron. Why? Because iron is above copper. That means iron is more reactive than copper. So if iron is more reactive than copper, so that's why iron displaces copper from copper sulfate, and instead of copper sulfate you will get if iron sulfate, and this displaced copper will be in the form of pure copper. So this type of reaction is called displacement reaction. So that's why we have these two products. That's why instead of blue solution we will get what? Green color solution. Why? Because the one of the product is iron sulfate. Its color is green color. So that's why you will see green color solution. And on the iron nail there will be reddish brown coating. So why there is reddish brown coating? This is due to the formation of second product copper, because copper is displaced by iron. This displaced copper will be deposited on the iron nail, and instead of copper there will be iron. So copper sulfate is changed into iron sulfate. Its color is green, so the blue color will become green colored iron sulfate solution. So this type of reaction is called displacement reaction. And how can we know the displacement reaction is possible? By checking the reactivities of metals. Next, an important point related to this displacement reaction, that's a metal reacts with a compound of another metal. So you might have seen that in this case we have discussed only about metals, that is displacement reaction by metals only. That is, a metal reacts with a compound of another metal only if it is higher in reactivity series as compared to the metal present in the compound. So that is, I have told you there are two reactants in a displacement reaction, and we can say that one of them is a pure metal, that it is not compound, it is metal only. But the second reactant is an ionic compound, or we can say that compound of another metal. Then how is the displacement takes place? The free metal should be more reactive than the metal present in the compound. Here, which is the free metal? Fe, iron. And which metal is present in the compound? The compound is CuSO4, copper sulfate. Which is the metal in CuSO4? Cu. So the free metal should be more reactive than the metal present in the compound. Here check the positions of Fe and Cu, iron and copper. Fe, the free metal, is above the metal present in the compound, that is Fe is above copper, means Fe is more reactive than copper. So that's why Fe is able to displace copper from copper sulfate and form FeSO4 and Cu. So we can conclude that in this reaction, displacement reaction shown by metals, in this case there are two reactants. One of them is pure metal and the another one is an ionic compound or compound of metal, and this reaction is possible only if the free metal should be more reactive than the metal present in the compound. In other words, we can say that the free metal, the metal should be more reactive than the cation of the compound. See, in CuSO4, which is the cation? Cu, copper. So in every compound, the first part will be cation. So that is metal only. So the metal, the free metal should be more reactive than the cation. So see, Cu is the cation and SO4 is the anion. So we can say that the free metal should be more reactive than the cation of the compound. Here, then only there will be displacement reaction. Then if the reverse reaction means if the free metal is copper and the compound is iron sulfate, then there will be no reaction. Why? Because we know that the free metal should be more reactive than the cation of the compound. Here, which in this case, which is the free metal? Cu. Which is the cation of the compound? Fe. So, for this reaction, Cu should be more reactive than copper. Check the positions of Cu and Fe. Cu is below iron. That means copper is less reactive than iron. So if copper is less reactive than iron, copper cannot displace iron from iron sulfate. So in this case there is no reaction. So for displacement reaction, the free metal should be more reactive than the cation of the compound, then only there will be displacement reaction. In other words, the free metal should be above the cation of the compound in the reactivity series, then only there will be reaction.